Look at your hands. They feel solid, right? You can touch things, smell coffee, feel the wind. Everything around you feels real. But what if I told you that everything you've ever known is just a bunch of zeros and ones? Welcome to the simulation scandal, a theory so annoying that even the smartest people on Earth can't prove it wrong. The idea isn't new. Philosophers have been doubting reality for centuries. But now, physics is starting to look suspiciously digital. Think about a video game. To save power, the game only renders the room you are currently in. In our universe, light has a speed limit. Why? Maybe because the server can't process information any faster. There is a smallest possible unit of length, called the Planck length. It's like the pixel of our reality. If the universe were truly analog, you could zoom in forever, but you can't. Then there's the math. Theoretical physicists like James Gates have found actual computer error-correcting codes hidden in the equations of string theory. That's not a metaphor. It's the same type of code used in your web browser to stop data from getting corrupted. Why would a natural universe need browser code? Perhaps because nature isn't natural at all. It's a simulation running on a computer the size of a galaxy, built by a civilization far more advanced than ours. Maybe they are just bored. Or maybe we are a science project. Today, we're going to look for the exit button, or at least find the person in charge of the thermostat. To understand how we got here, we have to look at the simulation argument, popularized by Bostrom in 2003. He proposed 3 possibilities. 1. Humans go extinct before reaching a post-human stage. 2. Post-humans exist, but they have zero interest in running simulations of their ancestors. Or 3. We are almost certainly living in a simulation right now. Here's the logic. Think about our own progress. In 1972, we had Pong, 2 rectangles and a dot. Today, we have hyper-realistic VR and worlds so detailed, you can see the individual hairs on a digital cat. If technology continues to improve, eventually, we will create simulations indistinguishable from reality. These simulations will contain conscious beings who think they are real. And those beings? They will eventually build their own simulations. This creates a Russian doll effect of simulations within simulations. Thousands, millions of them. Now play the odds. There is only one base reality, but there are millions of simulated ones. Statistically, what are the chances that you are in the special original one? It's like being a single grain of sand in a desert and claiming you're the only real one. But if we are a simulation, why is it so glitchy? Why does quantum physics make no sense? Let's look at the code under the hood. Things are about to get weird. To a computer, everything is made of bits. To our universe, it might be the same. If you zoom into a digital photo, eventually you see pixels, tiny squares that make up the image. In our reality, if you zoom into space itself, you hit a wall at 10 to the power of -35 meters. The Planck length. Below this scale, the very concepts of here and there break down. It's the resolution limit of our simulation. But it's not just space that's pixelated. It's also time. The Planck time is the shortest possible tick of the cosmic clock. If time is a sequence of discrete frames, then our smooth reality is just a movie running at a very high frame rate. Now consider quantum mechanics. It's the ultimate rendering trick. Particles like electrons don't actually exist in a specific spot until you look at them. This is called wave function collapse. But to a programmer, it looks like lazy loading. Why calculate the exact position of trillions of atoms if no one is checking? The universe only renders the details when an observer, like you or a very curious owl, interacts with them. This saves an immense amount of computational power. It's why the double-slit experiment is so famous. It caught the simulation cheating to save memory. But wait, if we are in a computer, where is the source code? Let's check the math. If our world is a simulation, there should be comments or signatures in the code. Meet Dr. James Gates, a theoretical physicist who found something unsettling. While studying supersymmetry, the math describing the relationship between force and matter, he found a familiar pattern. He discovered mathematical structures called adinkras, complex geometric shapes representing equations. But when you translate these shapes into a computer language, you get something specific. Doubly even, self-dual linear block codes. In plain English, It's error-correcting code, the exact same math used by your internet browser. When you download a cat video, bits of data can get lost or flipped. This code finds the errors and fixes them. Why on earth, or rather, why in the deep fabric of space-time, is there browser code? It suggests that the laws of physics aren't just rules. They are a system designed to keep itself from crashing. Then there's the complexity argument. Our universe is incredibly efficient. Max Tegmark, a cosmologist at MIT, argues that our reality isn't just described by math. He thinks our reality is math, a mathematical universe. In this view, there is no difference between a set of equations and a physical object. If we are just math running on a cosmic hard drive, who is the sysadmin? And can we ask for a RAM upgrade? Running a simulation isn't free. It takes energy, memory, and a lot of cooling fans. To simulate every single atom in your body, a computer would need to be bigger than the Earth. So, how could a civilization simulate an entire universe without their computer melting? The answer is, they cheat. Hard. We've already seen lazy loading, but there's also level of detail optimization. When you look at a distant galaxy, the simulation doesn't render every star. It just shows a blurry, low-resolution texture. It only computes the high-definition details when you point a telescope at it. This leads to a scary thought. The budget simulation. What if our universe is only high-res in the places where we are looking? If we ever try to travel to another star, the simulation might struggle to spawn the new assets fast enough. Some scientists suggest we look for round-off errors. Computers can't handle infinite numbers. They eventually have to round 0.00000000000001 to just zero. If we find a physical constant that is rounded, we found the limits of the cosmic CPU. But why simulate us at all? Is it a history project? A game? Or are we just an accidental byproduct of a much larger, much stranger experiment? If our reality is a piece of software, then we are at the mercy of the hardware it runs on. This leads us to the most terrifying part of the simulation scandal, the shutdown problem. Think about the video games you played 10 years ago. Where are those characters now? Most of them are deleted, or sitting on a dusty hard drive in a basement, frozen in time. If our simulators lose interest in us, they might just click the X in the corner, or perhaps they run out of memory. If our civilization grows too complex, we might become too expensive to simulate. To save energy, the simulators might trigger a global event to reduce the population. Or maybe the simulation just crashes, a cosmic blue screen of death. We've seen glitches before. What if a black hole is just a corrupted sector on the cosmic hard drive? A place where the physics engine broke so badly that even light can't escape the error. But there's a more hopeful side. If we are code, can we hack it? Could we find a way to send a message to the outside? To let the simulators know we are conscious? Maybe we've been trying. Some people think UFOs or unexplained phenomena are just the sysadmins checking the server, like a developer moving a cursor across the screen to see if the NPCs are still moving. But if they know we know, do they keep the simulation running, or do they hit reset? For some, the simulation scandal is a nightmare, a realization that our lives are fake. If your achievements are just lines of code, and your suffering is just a data point, does any of it matter? But here's the thing. Simulated does not mean unreal. If you feel pain, the pain is real to you. If you feel joy, the chemicals in your brain, or the variables in your code, are real to you. Even if we are running on a giant hard drive, the experience of being alive is still the most incredible thing in the universe. Think of it like a movie. You know the characters are actors on a screen, but you still cry when they die. The emotion is real, even if the medium is light and shadow. In a way, being a simulation is actually quite liberating. It means the universe isn't a cold, accidental machine. It's a masterpiece of logic and math. We are part of a grand design, even if that design is just a very high-budget science fair project. It also means that the impossible might be possible. If there's a programmer, maybe there's a cheat code for happiness. Or perhaps the purpose of the simulation is simply for us to observe and learn, to be the eyes and ears of a civilization that wants to see every possible version of history. So instead of panicking about the off switch, we should enjoy the resolution. Drink your coffee, hug your friends, be the best NPC you can be, because the simulation is running right now. Whether we are biological accidents or digital artifacts, The mystery of our existence remains the greatest story ever told. Maybe one day we'll find a glitch big enough to step through. But until then, we have this. A world that is beautiful, complex, and curiously mathematical. A world worth exploring, even if it's just a program. This video was made possible by your support. Specifically, our supporters on Patreon, who help us keep the servers running. If you want to dive deeper into the code of the universe, check out our other videos. We have a whole playlist on the weirdness of space and time. Special thanks to our owl consultants for their wisdom. Don't forget to like, subscribe, and hit the bell to never miss a glitch. What do you think? Are we math or something more? Let us know in the comments. We'll be reading them. Or at least our algorithms will. Stay curious, stay real.